In this video, I'm going to discuss the unit circle, all the quadrants, angles, and values. If you need to learn the quadrant 1 values and how they are calculated and constructed using special right triangles, you'll need to watch my first video. So my assumption is you know how I did this quadrant before I start talking about these. So understanding how the unit circle works is just understanding that it's actually designed and constructed as a way to quickly calculate values. And the way that works is when you look at the unit circle, you understand that the values, just the triangles themselves, they just keep repeating, which means the values will repeat. So I'm going to first start with the values that we see. For instance, this line right here is just the line that is the x-axis, and this point is 1, 0. And since this is just a circle with radius 1, it makes sense that this point over here would be negative 1, 0. And I'll put the negative on in a minute because it underlines a point that is super important to understand on the unit circle. And so this triangle here, that's 30 degrees here, is going to have the exact same x and y values here because it's constructed using the same 30, 60, 90 triangle as the one over here. And same thing with this one, right? So this one has the same x and y cosine sine values, and so does this one. They're all constructed using a 30, 60, 90 triangle in that orientation. So the same thing with the 45, 45, 90. It will also have the same x and y values or cosine and sine values all the way around. And then same thing with the 30, 60, 90 oriented this way. Sometimes people will call it the 60, 30, 90 rather than 30, 60, 90. So they all have the same values as well all the way around the unit circle. And the same thing will go even with the tangent values. So remember, tangent is constructed by taking y divided by x or sine divided by cosine. So this tangent value here has the same x and y values as this, so it will have the same tangent value. Keep in mind also that tangent is slope, so the slope of a linear angle or a line that is the x-axis, a horizontal line, is 0. So this tangent will have the same numerical value. Again, it will have a negative connotation, but we'll talk about that in just a second. Same thing here, same tangent value here, and same tangent value over here. Okay, so this one in my opinion is the easiest one to remember, because if you're dividing y divided by x and you have the same thing, you obviously are going to get 1. So all of these have a tangent value of 1. Okay, and then the last one, the 30, 60, 90 triangle oriented upward like this, we end up, if we divide y divided by x, we end up with root 3. Again, the calculation of how we did that is actually found on the video before this to construct the first quadrant of the unit circle. So that's the values all the way around. And what ends up happening is we end up doing something from Algebra 1 here. So what we end up doing at this point is understanding that this quadrant here is quadrant 1, just like a normal quadrant from Algebra 1. And so when I think about that, this quadrant right here has values that are positive for x in the world of trig, that would be cosine, and positive for y in the world of trig, that would be sine. So quadrant 2 would have negative values for cosine and positive values for sine. Quadrant 3 would have negative values for both, because it's the third quadrant and both x and y are negative there. And then the fourth quadrant would have, it came out looking a little weird, so I'm just going to rewrite it. This quadrant would have a positive x value, but then a negative y value, so positive cosine, negative sine. And then I'm going to take all of these values, which I just simply copied from the first quadrant, and I'm going to apply that concept from Algebra 1. So in this quadrant, all of the cosine values are negative, okay, including this one. This is negative 1, 0. And that's going to change my tangent values to also be negative, because remember, tangent is y over x or sine over cosine. So if I take this positive value and divide by this negative value, all those are negative. The tangent of 0 doesn't change because 0 is neither negative or positive. So down here, both of them are negative. Okay, so both sine and cosine are both negative. And the tangent values are positive. Now, why are they positive? Because it's y divided by x. And if you take two negatives and you divide them, then you get a positive. And then in this quadrant, only the y value or sine value is negative, which would again make the slopes of the tangents negative. In later math classes, you'll find that tangent is almost synonymous with the word slope. And it's actually very helpful in trigonometry. I mean, when you look at these tangents, you understand that this is a smaller slope value than this steep green one, which is a larger value. So these are negatives. Notice that they're on the same linear angle as their negatives, and that the positive ones are on the same linear angle as the positives. So now the next thing is, how do I figure out the angles that are associated with this? I mean, it's all good and well to know that these go here, but what angle is this? So to understand that concept, we need to understand what a reference angle is. A reference angle is the measurement something is away from the x-axis. So this reference angle is 30 degrees. Well, this is also 30 degrees, but it's being referenced from the x-axis over here. So that would become, right, if this is referencing from over here, we learned in geometry that this angle and this angle are 180 degrees apart, right? So if I reference 180 degrees, if I reference back 30 degrees, that's going to be 150. So this one would be 150 degrees, okay? And then if I reference down from there, I would reference 30 degrees beyond 180 degrees. So this would be 210 degrees. Okay, and same thing here. If I reference back from here, my reference is referencing from 360, which would make this 330 degrees. Okay, and the same thing now happens for all the angles involved. So if I were to take this and I were to go forward here, I get 45. If I go 45 degrees back from 180, I just simply take 180, subtract 45, and I would get 135 degrees. Okay, if I were to do that from here, right, if I were to go from here and go forward from 180, the reference is 180, I add 45, I would have 225 degrees. Okay, and then from this one, again, I'm not referencing here, I'm not referencing 180 anymore, I'm referencing 360. So if I go back 45 degrees from 360, I have 315 degrees. Okay, and so the same thing is going to happen with the 60-degree angle as well. It's just the same kind of idea over and over again. Okay, so here, and you start to realize that there's a lot of information on this triangle, right? I mean, on all these triangles, but it's all the same information, and you just have to understand how it works. And once you understand how it works, it's not nearly as intimidating. So if that's 60 degrees there, if I go 60 degrees back from 180, referencing 180, this would be 120. And then if I do the same thing going forward from here, this one is going to be so 180 plus 60, right? That's going to be 240. And then going the other way around, going this direction, I go back from 360. So 360 minus 60 is really easy. That's 300. Okay, so we have one last degree measurement to figure out, which is the one right here. And again, if this is 90 and this is 180, 90 plus 180 is 270. So now the question is, once I know the degrees, okay, how do I find the radian measures? And now a lot of people might say, well, why do I care about radian measures? Believe it or not, calculations later in trigonometry are easier to do with radians than degrees. And traditionally, upper level math classes and physics do everything in radians. So again, the assumption is you know how I got these radians in the previous video using conversions. I'm going to focus now on reference angles with radians. So if I reference this over here is pi. And that's really convenient and important understanding the rest of the angles. So if I take this pi measurement and I walk it up pi over 6, that means I'm subtracting it just like I do with the degrees. So if this is pi and I do it with the common denominator of 6, this would be 6 over 6 minus pi over 6. So this measurement here becomes simply 5 pi over 6. And believe it or not, it's super simple once you understand that idea, because this one will become 7 pi over 6 because I'm just going forward from pi, and pi would be 6 over 6, so 6 plus 1 is 7. Over here, when I walk this back, I'm walking it back from 2 pi, so I'd want to think about that as 12 pi over 6, so this would be 11 pi over 6. Okay, and that's the same thing for all the rest of them, but I just use the pi value and the 2 pi value that has a coordinating common denominator. So for pi over 4, this would become 4 over 4. If I walk it back 1, this would become 3 pi over 4. Okay, and if I walk it forward 1, that would become 5 pi over 4. So this one that goes forward, pi over 4 would be 5 pi over 4. Okay. And this one here, again, we're not doing pi over 4 anymore. We're not doing pi, so we're not doing 4 over 4 anymore. We're now doing 8 pi over 4. If I walk it back 1, this would be 7 pi over 4. Okay, and then the last one is the pi over 6s. Again, if I walk this forward pi over 6, if I walk it back pi over 6, I would think about this as 6 over 6. So this would be 5 pi over 6. And I'm sorry, that's not pi over 6, that's pi over 3, forgive me. That's pi over 3, so that would make this 2 pi over 3. So if I walk this back from pi, this would be 3 over 3, walk it back would be 2 pi over 3. Okay, and then going down this way, if I walk this forward pi over 3 from 3 over 3, this would be 4 pi over 3. And then this last one here would be 5 pi over 3. Again, explain to you how I got that. The way I got that one is I had 2 pi, which with reference to 3 would be 6 pi over 3. So if I walk it back 1, 6 minus 1 is 5. So that's a lot of information. When you look at the unit circle, there's one more piece of information, is that tangent is undefined here. So if tangent is undefined here, then it will be undefined also down here, because tangent, and this is the best way to understand this one, is to understand that tangent is a slope. And so when I think about that, I have to understand that this is a vertical line, and vertical lines are going to be undefined. So this undefined line at the top is still undefined at the bottom. So how in the world are you going to remember all this? Well, you really only need to know the first quadrant. And if you know the first quadrant, you can easily understand how to do the rest of the quadrants, because if you know the first quadrant, the values don't change other than a negative or positive. So the question now is how do I find the angles? So it's really important. The numerical angles people can usually figure out using reference. And again, using reference is really helpful, but there are some other things that occur. For instance, if I look at the pi over 4, I can simply count 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4, 2 pi. You can do that with all of them. So for pi over 3, I have 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Same thing with the pi over 6, 1 pi over 6, 2 pi over 6, because 2 pi over 6 would be a third, 3 pi over 6, 4 pi over 6, 5 pi over 6, 7 pi over 6, 7 pi over, all the way around. Another thing that's really helpful to understand is that the linear angles that are formed consistently on the unit circle help me to remember items that are across from each other. For instance, if I start here at pi over 6, this linear angle is simply adding pi. So that would be adding 6 over 6, and 6 plus 1 is 7 pi over 6. Same thing here. 4 plus 1 is 5. Here I have pi over 3, so 3 plus 1 is 4 pi over 3. It even works over here. 2 pi over 3, 2 plus 3 is 5. And again, that works because we're adding pi and have a common denominator. 3 pi over 4, 3 plus 4 is 7 pi over 4, 5 plus 6 is 11 pi over 6. So there's little things that help you in this that will help you learn how to use the entire thing. So what do we do with all this information? Again, the purpose of the unit circle is to provide a mnemonic device to help students answer questions like these.